Hi, everyone. Thanks for joining. So for those of you who are in the back of the room, you can get a bit closer because there's going to be some text on the screen. So if you can't read, don't hesitate to come closer. It's been a really long week. Lots of news announced. Thank you so much for being here. It's the last session of the last day of reInvent. I know you must be exhausted. I am. But it's been a really great week. So when we decided on making sessions, I took myself a challenge to present a session around DevOps, .NET, and AWS without speaking about containers, without speaking about continuous integration and continuous delivery. So what we're going to see today is a session that is more centered around how to develop applications for AWS. And I'm going to be showing a few demos using Visual Studio. Well, actually, I'm using a Mac, so I'm going to be using Visual Studio Code, which is the new free version that works on multi-platform. So I'm Julien Lépine. I'm a solutions architect. I've been working with AWS for the last 4 years now. I'm a Microsoft specialist and developer technology specialist. So I'm working in Europe with any AWS customers that has needs and projects around the .NET platform and the Windows platform. So one of the constants we have in development is that people want more. People will want more features, will want more scale, will have new use cases that you haven't had the chance to think about when you started the platform. But at the same time, the second law of thermophysics seems to apply to any development team. When you have a project that is running and you have a platform that has been in the market for a few years, the speed and the velocity of your development teams tends to go down. And that's what thermophysics says. Entropy in a system comes and grows with time to make sure that the system is going to be stable at the end. But as we know, we want to be moving fast for our customers. And as Werner Vogel said on the retrospective he published in March of this year around the learnings he had for the last 10 years operating Amazon Web Services at scale is we should build evolvable systems. What I find interesting in that sentence is not that we should build a system that will evolve and will be optimized for the next 10 years. It's that we should build a system where we will be able to replace parts or even replace the entire system without any impact to the customers. And that's a different vision of development and a different vision of building systems where you're going to be building a system where you'll be replacing just about everything. One such example is actually Amazon S3. When we launched S3 10 years ago, we can compare it to a small Cessna plane. It was flying, we had customers using it, but we knew from day one that the system we were building and we were putting in the market would not be the system we would have 2 years or even next year. The system would have to change. And what we've seen is that with any order of 2 of magnitude in change of usage of the system, we had to rebuild most of the system. So if we take back the analogy of the planes, starting from a small Cessna plane, we started with that small plane, started to have a fleet of 737, then grew to 747, and now we have a complete fleet of Airbus 380s to run Amazon S3. And at the same time that we've built that fleet, we've moved customers around from one system to another without them noticing, making sure that the experience and the APIs that you have access to stays the same as much as possible. So that evolvability is really one of the keys of developing system, and it's one of the mantras we have internally within AWS. A second sentence from Werner Vogels is, we should build primitives. And as AWS, it's really the way we work. We provide you with capabilities on which you can build your platforms, your systems. And we want to focus on providing primitives, really the key block that you will need for building your applications. That helped us last year release over 722 new services and features on top of the platform. And this year, we're on track to have more than 1,000 new features and services available on the platform. So one of the ways we have to achieve that evolvability and the fact that we concentrate on having primitives is really to focusing on what is the core concept of the platforms that we want to build. If we get back to Amazon S3, 10 years ago, we released a platform that was extremely simple. It was basically two APIs, put and get, available over HTTP, or HTTPS in that case. It's really built for simplicity. But over the years, we've had thousands and millions of customers using Amazon S3, giving us feedback on the platform, helping us define what would be the next generation of features we would deliver for Amazon S3. And as we gain scale, since we built a system that was focused on one core component, we're also able to optimize that component and lower prices over the last 10 years. So really making sure that we build these primitives is really important. And the second part of that framework, of that sentence is, we don't want to build frameworks. Frameworks are where your application will live. But when you start using a framework, you're going to be tied to the design decisions of the people that have built the framework. And if you're in the Node.js or even the .NET community, there's thousands of frameworks for building different kinds of applications. But these frameworks are really opinionated. They're built in a way where you need to fit the needs of the framework and the way it was built. With primitives, you're much more open. You can use primitives such as Amazon S3 to do just about everything you want. We won't tie you to a specific use case. And that is really one of the key when we build the platform, we try to have this model in mind. So when we move to enterprise architectures and applications architecture in general, typical enterprise architectures are built using the layered model. You have a database that's going to be storing the data for that application. On top of that database, you will have a data access layer. It can be automated object relational mapping. You can use entity framework. If you're using the .NET platforms, there's many ORMs available in the market. On top of that, people will start building a business layer where all the business rules of the application are going to be built. And later, they will want to add a presentation layer to be able to build that shiny new web application or mobile application or APIs that people want to use. And on top, you're going to get the user. What we see from years of experience on these architectures is that when you have an application that's built using this pattern, after a few months or years in production, you're going to start finding business rules in the database layer because it makes sense. It's just closer to the data, so I can do some transformation. Or you're going to have lots and even tons of business rules that are in the UI layer because it's easier to put it closer to the user. And what it means for the application developers and the operators over the course of the years is that finding the business rule that is generating a specific behavior in your application is usually a difficult thing. And there's three impacts that we have that we want to avoid. The first one is that when everything is built within the presentation layer, it's really difficult to have automated testing. You're going to have to use specific frameworks to have UI-based testing. But these frameworks require lots of computing power, lots of time to do all the testing. And if these tests were made in a fully automated way using programmatic access, it would be so much faster. Second thing is that you can't run these applications as batch because it's bound to a UI. And if everything is within the web page, running a web page as a batch is not the best thing. You're going to have to use scraping proxies and stuff to use the API, use the web page as a batch. It's not that efficient. And finally, what we see now, and it's something that we've learned over the years with AWS, when you build a platform or an application, that application is successful, you're going to have customers who will want to integrate that within their own application. So we want to use your geolocation data, your financial data, or any kind of data you have, or API you have within your application. And they would want to build up mashups or new applications on top of it. And if everything is bound to your presentation layer or with your database layer, it's getting really complicated. Another example, having automated testing when you have a database of 4 terabytes of products. Every single unit test should have the same database as a start. So that may mean you would have to provision tens of terabytes of data, or you would have to get a sample of the data, but create lots of databases for testing. if we had a way to remove dependencies on that data access layer and dependencies on that presentation layer when we build application, we would be much more faster in testing and delivering new features. So that is exactly why hexagonal architectures have been built. So hexagonal architectures were presented and the term was nailed by Alistair Cockburn, so one of the writers of the Agile Manifesto. It's also named ports and adapters. It's an architecture pattern within your application where basically you want to invert the design of your application. You want to build your application from the inside out. What you want to do is you want to have a business layer. That business layer does not have any specific dependency on what it's running on. It could run as a console application. It could run as a web application, an API, or any platform on which you want to run it. Because that business code would not have any dependencies on what it's running on. And to ensure that you don't have any dependencies, you want to build what we call clear boundaries. You want to build APIs and interfaces, if you're in the .NET world, that are actually defined by the business code itself. It's not using a framework that is saying, if you want to access data, do it that way. The business code says, I have this event, that event should get me some piece of data, or should call an API. And the business code does not have to care how that API is going to be called, if it's coming from a database, a web service, or any other source. What it gives you as well is you have strong APIs out of the box, because these APIs are driven by business demand. And that's the same for the protocols that you're going to be using for communication. If I have an application that is a banking application, I'm going to be speaking about deposits. I'm going to be speaking about withdrawals. I'm not going to be speaking about sending a message on a TCP socket for getting data out. It's really focusing on what matters for the application. And we'll see in the examples that we have later that what you can do as well with this system is you can basically, once you have a business environment that is fully defined, you can switch and replace completely all the interfaces to the outside world. And the application that you've built, you can scale it, you can change it, and you can use different services. So I don't want to be only speaking. What I want to show you, since we're in Vegas, is a sample application. So that application is the AWS simple Blackjack service. So rest assured, no money is involved in that. It's only credits, and it's stored in a cookie, so it's easy to get more money if I want. It's a web-based application. So I can use it from any browser. And we'll see, I've used the hexagonal architecture pattern, so we can even run it from other devices than web-based. It's a multiplayer application where many players can come, join the table, and play. And finally, it's a blackjack following the casino rules of blackjack. So on that, I just want to show you, and you'll see that I'm a developer, I'm not a UI designer. So it's not extremely shiny in terms of vision. So I'm a user, and I have a profile. On that profile, I have a picture, I have a name, and I have an amount of credits that is associated with my account. What I can do as well is I can join a game. So on that game, I can see back that I have my profile, so I'm still JS, which is Julian on Safari, because I have JF, which is Julian on Firefox. I have a number of credits, and my game is not started yet. So first thing I want to do is I want to join the table. So I have a quick picture that says Julian just joined the table. Once I'm in the table, I may want either to leave the table or join a game. I'm going to play. Why not? So I'm going to bet 20 credits on this one. Up. I have 1,275 credits, so 20 credits less than I used to have. And I could have another hand, or I can just start the game. So when I start the game, what I see is that I have a dealer, the dealer has a hand, and the second card is hidden. I have a specific end. In my case, I have 16 points, so a jack and a 6, and the dealer has a 7. So I can either hit or stand. So in my case, I'm going to stand. 16 is pretty good. And the player starts, and the dealer starts playing. Actually, the dealer has a 21, and I've been playing that game for quite a while now. I lose every time. I don't know how it's done. I use a cryptographically secure algorithm for sorting the data. So I have the cards. I use a random number generator to get that completely mixed up. The dealer has a 21 like 4 times out of 5. I just lose every single time. So here, if I look at it, well, I got a poor 16, so I lost. And then I can reset the game. I can do the same thing from another browser here, and as it's a multiplayer, I have the same table. I could join the table. I could start another game, and I'm going to have, so it's JF, Julian, and Firefox. So here I'm just going to leave the table. But one of the good things of hexagonal architectures, so that platform, we're going to see just right now, is built using that pattern. I have an AWS Blackjack core assembly where I have all the business rules for playing Blackjack. And it's hosted on IIS. Well, actually, it's using Kestrel, which is the IIS Lite that is running using .NET Core. And I use the file system for storing my profile data. So when someone uploads an image, it's stored on the local file system and served as an image. And it's a web application. So it's a pretty easy way to build an application, and we'll see how it's built just later. But what I can do as well, as I've been using the hexagonal architecture patterns, is I could actually pretty much go and start it from a command line interface. Why not? So if I go .NET Run, it's going to build my application, and actually here I can ask for help, and it's telling me what I can do. So I'm going to zoom just a bit. It's going to be better for everyone. Up. So I can do exactly the same things that I've done. So I can join a table. My name, yeah, okay, why not? And then I'm going to bet on that table. So I'm player 0. I'm going to bet 10. And then I can go. So the game is starting. I have a queen and a 3. I can either hit or stand. So here I'm going to hit because I only have 13. So I'm going to be willing to go more. I have a queen, a 3, and a 2. I'm going to again bet because I want to have this one. So I'm still player 0. And, oh, yeah, it's going to fail. Oh, 10. It's not a bet. It's a hit that I want to have. So I have queen, 3, 2, ace. I have a 16. I'm going to stand. So here I stand, and again, I lost because the player had a better hand than myself. So the dealer won again. He had a 5, a 6, and a 7, which makes him an 18. So he wins. But it's exactly the same code. I didn't change any single line of code to get it running on a command line interface, such as this one. It's not the best experience to get Blackjack running. But the good thing is that when you're in a plane and you have to develop, which I kind of did, it's an easy way to get started, try a few stuff, and get back. So easy way to have an application that is up and running. And during the rest of the presentation, what we're going to see is we're going to see some ways we can change the application from that simple application and make sure that as we have an application that's built using the hexagonal architecture pattern, we're going to be changing some of the APIs to use more advanced services because, as you can see, running an application from my laptop using the file system is not that cloud. So we'll want to have some more cloud services that are going to be integrated. So the first thing, and it's often one of the questions I have from my customers when I'm working with them on migrating an application to the cloud is, yeah, but my application has many files. So when you have a file, usually you're going to store it in a file system. That file system may be, in the case of my application, the local file system from my machine, or most of the time in enterprise application, you're going to have a SAN. This SAN may have a replication in another facility, and you're going to mount the SAN on your instance, and so on your virtual machine or server, and you're going to be presenting the data from the SAN directly to your users via the web application. It works. It's an easy way. It's fully native. Using SAN and using file system is embedded in every single API and every single framework that you have on all the platforms. But at the same time, you have some issues in terms of durability. As I said, instead of having one SAN, you need to have 2. You need to have fiber connectivity between the SANs. You need to have replication. You need to have a quorum. You need to have failover. It's a lot of work to get that running. Scalability. Once your SAN is out, you're out. So you need to plan from day one when you build your applications that if you will need to store a lot of data, your code needs to be able to spread the load on multiple SANs, multiple volumes. It's usually a pain. And finally, it's usually tightly coupled. If you have a SAN, okay, you have a SAN, but if you don't have a SAN, you're going to be storing the data on the local disk. So if you want to scale out, you're going to have to put multiple machines and copy the data. But what we could do is just, if it works, use Amazon S3. So Amazon S3 is a fully managed storage service on top of AWS. You know it by now. And the good thing with Amazon S3 is that it's fully redundant. It goes to scale as much as you want. And it's really easy to integrate within your application. So what we're going to see now is how to exactly integrate Amazon S3 within my application. Number 3. So I'm not going to be live coding. I'm going to be just uncommenting a bit, because live coding usually fails. So in my case, what I have and where I'm using the file system is for my players. So here on the left, I have my projects. I'm just going to get them closed, just so you can have a quick vision of my architecture. I have a few core projects, so that are storing the state for my game, and a second one that is storing the state for my profiles. So it's managing the users, the credit they have, whether they have a bank, credit, debit, everything that's going on. But they don't have a clue on how to get the data in or out. They just know how to process a state. So these are actually state machines. And if I look at, for instance, my core application, and I look at the dependencies that I have, the dependencies are extremely small. I just have a JSON serializer because it's often easy to have a JSON way of showing the data. But apart from that, I don't have any dependencies on IIS. I don't have any dependencies on web services or databases. Everything is as simple as it can be. And it's really one of the ways that I can make sure my application will not change much. And that application defines what we call ports. So it has a context. And that context say, I need to have someone who's going to be able to give me the current game that the user is playing. A second one that is a bank. I want to be able to get money or to get credits from someone and give him credit backs. And the third one, I want to be able to notify people of what's going on. And that's all my business application needs to know to get access to that outside world for playing Blackjack. And I have a second business API that is centered around the profile. And that profile has a context as well that just says, I need to be able to load a profile, to save it, and to notify that something has changed. That's it. I don't have any other dependency. And on the other side of the game, what I have is I have adapters. So I have the ports defined in my business code, and then I have the adapters. And the adapters are going to be highly business specific. I'm going to be speaking about logging. I'm going to be speaking about the platforms that I'm hosted on. But the good thing is that it's only in the business code. So that is it's not in the business code. It's actually hosted within the web application. So every single web-related code is only in that application. So what I'm going to be changing now, and what we'll see during the next few examples, is I'm not going to be touching the business code at all. In my case, what I want is I want to be able to store the data and store the images of my users directly on Amazon S3, because it makes more sense. So here, what we can see is that I have a small piece of code. It's pretty simple. It takes data that is uploaded via a form, and that data, I just name files, resize the image using one of the libraries that is available on Nuggets, and I save the data. So really easy. And when we see it running, I get to my profile, I edit, just select a file, and I'm going to be selecting, no, this one is the one I have on the other one, Julian Small. That's myself in small. I save, up. Here you have me. So easy way. And what I can see is that the file is stored on my file system. But yeah, it's not the best way to do that when you're in the cloud. So what we would want to do is actually remove that piece of code and just replace that piece of code with another one. And as you'll see, it looks a lot like the previous one. If I'm failing to close my comments, that's going to be difficult. So the second model, as you can see, is pretty much exactly the same code. I take my files, I resize them, I store them as temp file instead of storing them in the web root of my application. And then I just have one API code, which is put object. in async, so I'm waiting for it because I want to have it in a synchronous way. And then I just generate the URLs that are going to be stored in my profile. So here, if I just save, and by the way, I'm using a specific tool from, I just failed something, because it has to, 133. Up. If I save it, up, it's building. What is it telling me? Expected. Not expected. I just changed something, I believe. Up. I save this one. I save. Oh, I don't know why this one got removed. So it should build now. It's been running forever. I mean, I've been playing with it for a long time. I'm gonna just get back. Player controller 142. You know how it works. Image destination, file delete. I'm gonna generate crap, but that's okay. So I'm loading again. Off I go. It's running, finally. Yeah, demo effects. That's okay. So if I edit, and if I take a new file that I have, so it's reloading the application, I choose the file, and then I just take the same ones that I had before, save. It's going to upload the file, it's going to save the file, and it's going to upload it to Amazon S3. So if I want to look at how it's going on Amazon S3, actually I can go to the Amazon S3 console. I have a bucket that I have created, which is called SBS. I have nothing in it, and if I refresh, I have a profile folder, and on that profile folder, I'm going to find a thumbnail and an image file that have been generated. So the local files have just been uploaded to S3. The good thing about it is I don't have anything to do about it now. It is fully functional, it works, and it's backed up. It's automatically going to go to scale. So really an easy way. And as you've seen, the code change are really easy in that space. So I hope that the next demos are going to work even better. So the first thing, it's a game. And like many games engine, we tend to have state in memory. When I have a game, I have that object, which is my current game that has been created. And everything is stored in memory. It's really an easy way to do and to play with, to have a game engine. And it's the way most of the games engine actually run out in the field. So easy, fast, no code necessary to do the backup. But point is, if my machine fails, I lose the state. So there's many ways to have that in-memory state replicated to multiple machines. You could use state replication or distributed caches or stuff. But what I want is, I want an application that scales as much as possible. And I want an application that's going to be stateless. So what I could use for being stateless on my application is actually use a database. I mean, it's been running forever. So we could use a relational database for storing my state. But the point is, it's a bit cumbersome because I have an entity that is my game, so I want that entity to be stored and to be managed in an efficient way. And I want to scale as much as I can. Scaling a relational database is still pretty hard. So in my case, what I would want to do is, I don't want to move to NoSQL databases. And I will want my state to be stored and managed in Amazon DynamoDB. DynamoDB is a fully managed NoSQL database engine. And we'll see that integrating it within an application that initially was stateful is actually pretty easy. So if I get back to my code, my player controller is still the same. Here, what I can find as well is that I have everything here. But in my game context, which is the one I want, my state here is in memory. When I don't have anything, I'm creating a new object. What I could do is just command that port. And instead of doing it, what I will do is, if I don't have a state in memory, actually what I'm going to be doing is I'm going to be loading that state from the database. I'm just going to do, again, one zoom. That's going to be easier. Display, zoom in. Yeah, it's getting big. So here, what we have, these 3 lines of code, which is load table, get item async, and wait, what it gives me a document that has all the information from my state directly from the database. And what I will want to do now is I will want as well to be storing that state in the database. So the last part is when I have a notification that says something changed, I'm going to be storing my state in the database. So that's nice, it works, but ASP.NET MVC has some interesting features that are useful. In my case, what I'm going to be using is the startup environment. So here, I have a singleton, which is my game context. I have one game context per application. What I want is, I want a game context per user, so that any request from a user is going to go to the database, get the state, process it, save the state back to the database, and off I go. So I'm fully stateless. But it has to be bound to the state of my application. And ASP.NET MVC has really that nice way of using dependency injection, which is one of the best things you can get if you want to have hexagonal architectures, where instead of having to hard code everything will be created for you. So here, what I've done is I've created a game context here. Said it's scoped. And that game context will be automatically created by any class that needs to have a game context. So I don't have to create the code and to pass it to every single class. If a class has it in its constructor, it's going to be using it. And I'm using that feature exactly here to get access to many objects. Here, within my game context, I need to get access to the profiles. ASP.NET MVC creates it for me using dependency injection automatically, so I don't have to define and to design anything. And the same for getting access to DynamoDB, and we'll see later Kinesis. So ASP.NET MVC gives you that ease of use for creating applications at scale. So I'm going to build the application now. And up. I'm going to even use a tool which is .NET Watch. If you've used ASP.NET .NET Core, actually .NET Watch, what it's going to do is it looks for any file modification within your environment, and if it finds one, it restores the application by rebuilding everything. So in case of demos, when it won't work, it's really good. So I'm back, and what I want is I want to be playing a game. So I'm going to go back to the game. It's loading the app. And once I'm going to be in the game, I'm going to be able to see that we have a state that will be created in the database. Hello. The demo gods are definitely not with me today. Is it doing anything? No, it is indeed doing anything. I don't know what. Yep. So, it's nice, isn't it? But it doesn't work. Web host, executing action, but the state is valid. It's just taking its time. So in the meantime, we're going to go to exactly the next phase. You'll see the state in the database. What's interesting here is to show that the state will be stored in my DynamoDB table directly. We'll see if it has a state or not, or if I just lost the network, which may be the case. Does anyone have a network jammer or something? It may happen. Yeah, server error, so I just lost the network. So just hold on a second. Deactivate Wi-Fi, activate Wi-Fi. I love it when it does it. Do demos with network. Okay, so that's not a problem. We're going to switch to the next, and network is going to come back in just a minute. So we'll see that the database is going to be used for storing the network. But when you don't have network connectivity, it's tough to get a database. Next thing we want is we want to be loosely coupled. Because here, when we looked at the code, my application, what it's doing actually, it's reading a file, and it's resizing the file directly from my ASP.NET Web application. And if we expand that, so it's a simple application that is just resizing profile images. But what I see a lot in enterprise applications is that you have an application that proposes you to download a report, for instance. When you click on that button, there's going to be a thread of the application that's going to be generating the report. It's going to be processing, getting lots of data, using lots of memory and CPU, and then you're going to have the report. Thing is, When you start having 500 users that are asking for just different reports, so you cannot reuse the data at the same time, you're going to have 500 threads that are running on your application, which may not make sense. So what we want is we want to have loosely coupled architectures where my web application is going to be only focused on providing web kind of features, and I'm going to have backend services that are going to be processing my data. And one of the last announcements we had from yesterday was the support of C# for AWS Lambda. And what we could do, actually, instead of processing and resizing the files directly within my application, I could actually use AWS Lambda. So we've seen that we can store the data on Amazon S3. So if I get back to the code that I had before, exactly the ones that I had in the first demo, here in my player controller, my demo one was I have the file locally. And I just moved it to get it stored on Amazon S3. But what I stored on S3 were the images that were used by my users. Here, what I want to have is, actually, I just want to store the source file on Amazon S3. And I want S3 to be able to do everything for myself. So the code within my application is going to be even smaller. You see, I don't have any resizing. I don't have anything. I just take the file and put it on S3. And by the way, I could even generate a URL that would allow my user directly to put the file on Amazon S3. So that's the first step of that demo. And if the network is back, which hopefully it is now, so it should be better. I lost Firefox, sorry. Up. So here, okay, I have it. So we're going to see how it goes just right after that. If I go to my bucket, which is a bucket in US West 1, what I can do as well in that bucket is look at what we call events. And here, what I have is I've just created an event that is called resize image. For any new object that is created on Amazon S3, that element will automatically call a Lambda function. And that Lambda function is called image resize. And what's really important and really good in that space is that instead of having, and you see I have many classes in my ASP.NET web application, what I want is I want to have a file that is, and I want to have a project that is as small as possible. So here, what I've built on the left is a simple project that is image resizer, and that image resizer has a single class. And that single class, what it does, it has one function, which is a handler, and that function will, in terms, get exactly the same code that I had before. Take the file that was on S3, download it, resize it, and store it again on Amazon S3. Really an easy way to build the application. And by the way, what it does, I've removed all image manipulation programs and references from my ASP.NET web application. It's going to be a lighter application, faster to run. So here, I've just made the change on the player controller. So hopefully, network is back and it's going to be willing to play with me now. Nope. Let's get back to Safari. So if I get back to my profile now, please tell me you're back and running. OK, it's better. So I can edit. I can get back to the files that I had, which is myself, very small, choose, save. Yep. And I've just saved the file. Took a couple seconds to get it resized. And what I've done is actually, if I get back to my S3 environment here, in my SBS folder, if I refresh, I now have an SRC folder. And what my code does is actually just upload the file to SRC. And the event automatically, what it does, so we see it on Friday, December 2nd at 12:38. If I go to my profile environment, at 12:38 and 41 seconds, so less than 2 seconds later, my files have been resized, have been dropped. And the code that I had to write was really simple. It's just a copy-paste. But that copy-paste helped me get a more leaner application. So if I now get back to my game, so game here, I can join the table. And I can join the game, and again, bet 20 credits. So I have something, I can start the game. And what I will want to know, and what I will want to see, is that in DynamoDB, my state is now fully stored and managed. And I can see the list of players, the keys, the cards, and everything that's going on. So storing data in DynamoDB, which was the demo that was supposed to be working before, is really an easy way. It's a map. So I just take a JSON and serialize my object from .NET, store in DynamoDB. I get them deserialized when I need them. Really an easy way to get started with the platform. And DynamoDB can scale to millions of requests per second. So even if you have a large site that has many users, it's going to scale for you. So you don't have to worry about state and replication and stuff. It's automatically done. Third example that we have is analytics. People want to have business insights on their application. They want to see what's going on. And the traditional use case is you have day plus one BI. So your business intelligence processes will come getting data from your relational databases, get via an ETL processed every night, and then you have the reports. What we see, and even more specifically, in the case of a game, people will want to have real-time analytics. They want to be able to go see the data, play with it, browse it in different ways. And we have multiple services for doing that. So we have Athena, we have Redshift, we have EMR. But for real-time, Kinesis is really one of the key elements here. You can get a Kinesis stream that is going to be storing your data or multiple millions of events per second if you want. And that Kinesis environment can be fully integrated with Elasticsearch service within a few clicks or with just one deployment. And what we're going to see here is that integrating Kinesis within your application, again, is pretty simple. So I get back to my code, and so I can close the process here. My application is running, and what I want is I want to be able, in my game context, when I have events, I want to be able to send the events directly to Kinesis. In that case, the only thing that I need to do is, again, I'm going to use serialization from JSON. So I just take my notification, which is an object that was built and sent from my business tier, so nothing web in that space. If it's a player notification, I just add an ID to make sure that all the events from the same player go to the same place. So it's easier for having at-scale analytics. And I just then call put records. Put records is going to send the data directly to Kinesis, and my data is going to be stored. I'm just going to look up. OK, I'm good. So here, my application is now back up and running. And if I get to my Safari, I go to a game, again. I started on Firefox last time, so I guess I still have a hand in Firefox. So a 7, yeah, I'm conservative, so I should never do stand on a 7, but we could. Oh, he won. Sad. What we can see now is that maybe you've seen when I was playing with the text version of the code, it's running and it's displaying a lot of events, what we call the notifications. That's business notifications, when something changes, when there's a new state, when there's players betting money or losing money or winning money. What I can do with that is actually, they're sent now to Kinesis. And using Kinesis, I can get it running directly in Elasticsearch. So I have a cluster that I created, analytics cluster, and what I've done with that cluster is actually get data in. So here we see in the last hour I haven't been doing much, but then in the last few minutes, I've been starting to play with my data. So any analytics event that I send from my application is going to be sent to Kinesis, directly processed by a Lambda function, and then stored in Amazon Elasticsearch. And it's Kibana, so I can play, I can have different visions, I can browse through the data, zoom in, see what's going on. And it's really, you have all the features from Kibana. And if I go to the Discover, I see that I have many events that are available. I can zoom on the events. So yeah, I have access to everything. All my events have a date, so I can even have histograms of what amounts have been processed, won by the users. So really getting analytics on your application, again, is just a few lines of code away. But it's not all. I said I would be speaking about DevOps. One of the mantras around DevOps, and that's been said again by Werner Vogels, is one of the things we have within Amazon. It's the you build it, you run it philosophy. And when you build an application as a developer, usually you package it, you send it to someone that's going to be running it, and off you move to a new project. When you want to be DevOps, no, you're going to be, as a developer, the one that has a pager. So if the application fails at 2 a.m., you're going to be woken up, and you're going to have to work on it. So you will want to have applications that are easily manageable. And to do that management, there's 2 key elements that you need to have. The first one is logging. You want to make sure that you can have visibility over everything that is running in your application. So in my case, what we've seen in the demos is that I have tons of logs that are output by the application. Web pages, information from my users. I have a lot of information. But everything is stored locally. It's either in the console output or in the local file. And actually, when you have an application that is at scale, getting to 55,000 local files to get the logs that you want and making the correlation is not the best way. What you want is you want to be able to get the log in a central place and get that central place easily accessible. And that's actually exactly what we have with Amazon CloudWatch Logs. CloudWatch Logs is one API away, again. So what I've done here is I've just created a simple class, which we call the logger. And what that logger does, it takes the logs from the .NET frameworks and sends them directly to CloudWatch Logs. So it's in my CloudWatch environment. I have a logger class. So it's not a big one. It's like a couple hundred lines of code, so really not that big. And what it does, it takes the logs directly from the .NET framework, packages them in JSON, sends them to CloudWatch Logs. So what I can do now is just, again, using the dependency injection features from .NET Core, is instead of having local logging for my application, what I could do as well is just get to using my specific logger, which is CloudWatch Logs. I just save. And I'm using Watch, so it should be building my application, and it's running now. So it now works perfectly. And so here, I can refresh. So this user has lost. It's the other one, but it's not a problem. I can reset the game. I can join a table. And what we're going to see in Firefox here is that I have a console, which we call the CloudWatch Logs management console. And what I have inside of CloudWatch Logs is what we call log groups. I've created one that is Blackjack, which is a default name for my Blackjack command. And what it does, you see log is coming from less than a minute ago, so 12:47. I have access to the logs of everything from my application. Everything is available in JSON. So from one machine or multiple machines, I can have thousands of machines. All the logs are going to be centrally stored in here. And if I want to have specific information around, let's say, what's happening in my game, do I have any event that is in my game, I can filter them, I can see them. And if I go to Blackjack here, make a refresh, and join the game, for instance, again, I'm going to be putting 20. So I've done some modifications on my game. Within a few seconds, I'm going to have the data that is going to be showing here, because I just have to filter it. So really a nice way and an easy way to get access to your data at scale. And again, I only have one log stream that is here. I could have tens of log streams because I have many machines. So here, again, filtering, really easy to get your data out. And you see 47, please come. Oh, did it create a new one? Maybe it did. Okay, demo gods, as usual. So getting your logs, getting the capability to analyze them, show them, browse them, and store them at scale is really one of the key points. And if you've heard Andy's keynote, which I believe you did, security should be fully automated. These logs that are stored in Amazon CloudWatch Logs, you can have Lambda functions. You can have security information and event management processes that are going to get the logs, process them, and proactively block applications or block bad patterns on your application. So really a powerful way to be scalable. But I said the second one that you want to have in terms of visibility for your application is metrics. You want to be able to make sure that the metrics that matter for your application are going to be processed and delivered directly to your application when it's needed. And in that case, we do have a service that is built for that, which is Amazon CloudWatch. But CloudWatch, by default, what it does is it takes the data from the host. So you're going to have the CPU utilization of your machine. If you use DynamoDB, you're going to have lots of metrics around the database. But what we want as developers is we want to know exactly what are the metrics that matter within our applications. How many players do I have in parallel? How many bets, how many moves do I have per second or per minute, depending on the case? And again, by using some of the .NET framework features and the integration with CloudWatch, what you can do easily is integrate that within your application. So again, I'm going to get back to the code. And here, what I can do is just, I had a monitor. That's, again, a small class that was built just to get data and store it in CloudWatch. What it does, it creates metrics. So I'm going to create metrics for the amount of credits that have been bet on the platform, how many gains, how many losses. So I'm going to have a few metrics around these ones. And then I'm just going to use, again, the dependency injection features. So in my context here, what I can do is I'm going to get a logger and a monitor. And if I get to my bank here, what I can do easily is say, when I have something that is happening, so either someone is making a deposit or someone is earning money, actually, I could have it automatically processed. And same in the context, I can have other data that is relevant that is going to be stored. And in my case, client. Don't ask me why. When you have analytics, the analytics is good. Bank is here. It's startup. Startup, what I'm going to do here. Create service, CloudWatch. I should be good now. CloudWatch, oh, okay, it's here. Okay, I don't know why. So my application is now started. And what I can do now when I play on my platform, so if I, again, do some actions, if I join, if I, again, do different stuff, what I'm going to have directly here is CloudWatch is going to provide me the ability to do dashboards. And with AWS dashboards, you can actually have them build up from the ground up and directly attach to your AWS personal health dashboard. And you're going to have access to these metrics. So here, what I've done is I have metrics that have been created, and I have bets, losses, so I'm not going to get much data here because I'm the only one playing. But here, the metrics that matter and coming directly from my application are going to come up and are going to be available directly in CloudWatch. So I can have alerts and saying, that's weird, I didn't have any player making any bet in the last 5 minutes, maybe something is broken. And actually, making sure that you have business metrics that are going to be driving your platform and not only technical metrics is a really powerful feature of AWS and of managing your application. So what we've been through, we started with an application that was only a web application serving users. What we've done is we've added state management, we've added analytics, we've added metrics and logging. We've also added loose coupling with Amazon S3 and Amazon Lambda. But at the same time, as you see, we were able to integrate and apply this architecture to a console line client, a CLI. So actually what we could do is we could potentially integrate it with Alexa. Easy way, you have a Lambda function from Amazon Alexa that would be called when someone says hit or stand. And it could directly integrate and play with the game. Same thing, you could add mobile clients. They would be using exactly the same state engine. It would be really simple for you to integrate that and get your application at scale using this hexagonal architecture pattern. And all this modification, which is really the key message I wanted to get here, I haven't touched a single line of code from my business side of the application. Everything has been done using the ports and adapters pattern. I've only changed what's on the side of the application. And if you use that pattern and the services that are available on top of AWS, and remember, we have over 70 services. We announced just many, many more just this week. You're going to be able, using that pattern, to keep on optimizing your application for the long term. So your application is going to finally become evolvable. The core business may not change, but actually everything that is supporting your application for making sure that it runs for the long time, it's evolvable, and you can keep that velocity in the long term, you can use the APIs and you can use the value-added services that we have. 722 new features over 70 services last year, or about 1,000 new features this year. So you're going to have plenty of work to do to optimize your application for the long run. To finish, you can also host your applications. So here what I've been doing, I've been running my application on actually my Mac and using the AWS value-added services. You can do that on Windows, you can do that on Mac, you can do that on Linux using .NET Core. It's still pure .NET. You're going to be developing in Visual Studio or Visual Studio Code, and everything is going to be integrated. You can also use Amazon EC2, of course, and once you're on Amazon EC2, you have plenty of options, either running it on Windows or running it on Linux. And depending on the way you want to operate, you can either use AWS OpsWorks, Chef as a managed service on top of AWS. Your application will be automated, you can patch, you can manage your application in the long term. Elastic Beanstalk, you're a developer, you don't want to have to do anything to the application platform. Just put it on Beanstalk, it takes .NET application, runs them at scale. It scales automatically. And finally, the Amazon ECS team has promised us publicly that they're going to be supporting Windows Server 2016 pretty soon. So you're going to be able to build containers. And what it means is that that scaling of machines that can take a few minutes to start a new virtual machine, using containers, you're down to seconds. So you can scale every independent part of your application where it makes sense in mere seconds. And finally, what you've seen here, we can use AWS Lambda. It's pure C# code. As of yesterday, Lambda does support .NET Core, so you can use C# or any other language from the .NET Core family and run it on Lambda. And by the way, it's integrated with API Gateway. So that same application that I've shown you, we could deploy it on Lambda with API Gateway. I wouldn't have any single server to manage. That scaling would be fully automated from one user to millions of users without having to do anything. State being in DynamoDB, files being in S3, and analytics being in Elasticsearch, logs being in CloudWatch logs and CloudWatch. I don't have any need to get access to that machine anymore. So I'm going to be able to move to Lambda. And we've just announced the SAM, so Serverless Application Model from AWS, where basically your Lambda functions will be described, packaged, and deployed automatically on top of AWS. So to finish, what I recommend you to do, go play with the hands-on labs. They're not closed now, so if you haven't done so, please go downstairs, use the hands-on lab room. We have plenty of labs. We have hundreds of labs that are available. Look at the AWS SDK. It's full .NET featured SDK, available in Nugget. And you have Lambda integration. So deploying a Lambda function using the AWS SDK is just one command line away now if you have a .NET platform that is running. Look at the Architecture Center. The Architecture Center provides best practices and blueprints of the most common architecture patterns that you'll see on the platform. And finally, I cannot encourage you enough to go speak to the training and certification team. We can train your teams, and you can get certified on top of AWS. And by the way, as we're in reInvent, if you're certified, you have specific goodies, you have an appreciation event, you have a lounge that is for you. So really lots of benefits of being certified. And by the way, it's really a great experience, and it's going to be of great value to you in the long term to be an AWS certified professional. On that, I want to thank you. I wish you all a safe trip home, and thanks a lot for being here.